This is an audio-visual presentation on circle theorems. Now, let's consider circles in general. Considering the circle as shown, AB is called the diameter of the circle, and the diameter is a line that divides a circle into two equal halves. So line AB is called the diameter. Now line PQ is called the chord, and the chord is a line that divides a circle into two segments. We have the minor segment, that is the shaded portion of the circle, and we have the major segment, that is the unshaded portion of the circle. We have the minor arc, that is arc PRQ, that is the arc forming the minor segment, and we have the major arc, that is arc PTQ, that is the arc also forming the major segment of the circle. Now, considering the circle as shown, there are two angles at the center of the circle, and the center of the circle is O. Now, the two angles at the center of the circle are alpha degrees and theta degrees. Theta degrees is the reflex angle. A reflex angle is an angle that is greater than 180 degrees but less than 360 degrees. So when you consider the two angles at the center of the circle O, at the center O of the circle, theta degrees is the reflex angle since it is the angle greater than 180 degrees but less than 360 degrees. So theta degrees is the reflex angle because it is greater than 180 degrees but less than 360 degrees. Now let's consider the theorems of a circle. Theorem number 1. Considering the diagram as shown, AB is a chord. The circle has center O. The chord AB subtends an angle of theta at the center of the circle, and the same chord AB subtends an angle of beta at the circumference of the circle, that is at the point C. Now, from the theorem 1, theta is equal to 2 beta. That is the angle that the chord AB subtends at the center of the circle is equal to 2 times the angle that the chord AB subtends at the circumference. And so theta is equal to 2 beta. That is when you multiply the angle that the chord AB subtends at the circumference, that's at point C, by 2, is equal to the angle that the same chord AB subtends at the center of the circle, that is theta. And so the angle theta is equal to 2 times the angle beta. So theta is equal to 2 beta. Now, let's look at this example. The figure shows a circle with center O. So the center of the circle is O. The arc PQ, that is PQ, is an arc. So the arc PQ subtends an angle of 80 degrees at the center. That is the angle as shown. The angle PQ, PRQ, that is angle PRQ equals X degrees. That is this angle X. Now from the question, we are asked to find the angle X. We are asked to find the angle X. Now let's look at how best we can solve this problem. Considering the diagram in the question, from the question, we know that PQ is an arc, and so the line drawn from P to Q is called the chord. Now, the chord PQ subtends an angle of 80 degrees at the center, and that same chord PQ subtends an angle of X at the circumference of the circle, that is at the point R. Now, by the theorem 1, we know that when we multiply the angle that the chord PQ subtends at the circumference by 2, we are getting the angle that the same chord PQ subtends at the center. That is the angle that the chord PQ subtends at the center of the circle is equal to 2 times the angle that the chord PQ subtends at the circumference. That means that 2 times x is equal to 80 degrees. So if 2 times x is equal to 80 degrees, how do we solve for x? We have to divide the left hand side by 2, and we divide the right hand side also by 2. When we divide 2x by 2, we are left with x, and this is equal to, when we divide 80 by 2, we have 80 divided by 2, and 2 goes into 80 40 times. That means that the value of x is equal to 40 degrees. So the angle x equals 40 degrees. The angle x equals 40 degrees. Now theorem 2. AB is a diameter, and the diameter is a line that divides a circle into 2 equal halves. So if AB is the diameter of the circle, then the angle that the diameter of a circle subtends at the circumference is equal to 90 degrees. Now if AB is the diameter of this circle, the angle that the diameter AB subtends at the point D is theta, and the angle that the diameter AB subtends at the point C is beta. Now from the theorem 2, the angle that the diameter subtends at the circumference is equal to 90, and this means that theta is equal to beta is equal to 90, because the angle subtended by the diameter AB at point D is theta, and the angle subtended by the diameter AB at point C is beta. And since the angles are the same, it means that theta is equal to beta is equal to 90 degrees. Take note that if AB is the diameter of the circle, then the angle that the diameter subtends at any point on the circumference is equal to 90 degrees. So theta equals 90 degrees and beta equals 90 degrees. That is why theta is equal to beta is equal to 90 degrees. Now theorem 3. Theorem 3. Cyclic quadrilateral. Cyclic quadrilateral. That's a quadrilateral in a circle. So A, B, C, D is a quadrilateral, and a quadrilateral is a four-sided figure. So we have A, B, C, D to be our quadrilateral in the circle. Now when we have a cyclic quadrilateral, that's a quadrilateral in a circle, the sum of the opposite angles is equal to 180 degrees. Now when we consider the quadrilateral A, B, C, D, we can see that angle A is opposite to the angle C, and angle B is also opposite to the angle D. So because the sum of the opposite angles is equal to 180 degrees, it means that angle B plus angle D is equal to 180 degrees. That is how come we have B plus D is equal to 180 degrees. Also, angle A is opposite to angle C, and so because the sum of the opposite angle in the quadrilateral within the circle equals 180, it implies that A plus C is also equal to 180 degrees. Now let's take a look at this example on theorem 3. Let's look at this example on theorem 3. Now the figure shows a cyclic quadrilateral PQRS. That is PQRS. This is a cyclic quadrilateral. That is a quadrilateral within a circle. Now find the marked angles. So from the quadrilateral, considering the angles in the quadrilateral, we have X, Y, 150 degrees and 85 degrees. So since we are asked to find the marked angles, it means that we are supposed to solve for the angle Y and the angle X. Now from the theorem 3, if you have a cyclic quadrilateral, that is when you have a quadrilateral within a circle, the sum of the opposite angles is equal to 180 degrees. Now we can see that 150 degrees is opposite to the angle X, and therefore X plus 150 degrees is equal to 180. Also, Y is opposite to the angle 85 degrees, So we can also write that y plus 85 degrees is equal to 180 degrees. Now let's proceed. This is the solution to the problem. Considering the cyclic quadrilateral, the quadrilateral is PQRS. Now when we consider the angles within the quadrilateral, we can see that angle X and angle 150 degrees are opposite angles. And so the sum of the opposite angles in the quadrilateral is equal to 180. That means that X plus 150 degrees is equal to 180 degrees. So if X plus 150 degrees is equal to 180 degrees and we are solving for X, it means that we are grouping all the angles on the right hand side. So plus 150 degrees on the left hand side becomes minus 150 degrees on the right hand side. And X is equal to 180 degrees minus 150 degrees. Now when we subtract 150 degrees from 180 degrees, the answer is 30 degrees. Also, angle Y and angle 85 degrees are opposite angles within the quadrilateral, and the sum of the opposite angles is also equal to 180 degrees. So Y plus 85 degrees is equal to 180 degrees. So if Y plus 85 degrees is equal to 180 degrees, then it implies that Y is equal to 180 degrees minus 85 degrees. Now when we subtract 85 degrees from 180 degrees, the value of Y is equal to 95 degrees. The value of Y is equal to 95 degrees. Take note that the angle Y and the angle 85 degrees are opposite angles within the quadrilateral, and so Y plus 85 degrees is equal to 180 degrees. Therefore, making Y the subject, plus 85 degrees on the left hand side becomes minus 85 on the right hand side. So we have Y is equal to 180 degrees minus 85 degrees, and this is equal to 95 degrees. Now let's look at the theorem 4. AB is a chord. The chord AB sustains an angle of theta at point C, and the same chord AB sustains an angle of beta at point D. Now because theta and beta are all angles suspended on the circumference by the chord AB, it implies that the angle theta is equal to the angle beta according to the theorem 4. I repeat, AB is a chord. The chord AB sustains an angle of theta at point C on the circumference, and the same chord AB sustains an angle of beta at point D on the circumference. Because these two are all angles suspended at the circumference from the chord AB, it means that theta is equal to beta. That is from the, according to the theorem 4, theta is equal to beta. The angles suspended at the circumference, that's at the point C and D, by the same chord AB are the same. So theta is equal to beta. Now let's consider the theorem 5. AB is a chord, and the chord AB sustains an angle of theta at the point C. PQ is also a chord, and the chord PQ sustains an angle of beta at the point R on the circumference. If the length of chord AB is equal to the length of chord PQ, then it means that the angle theta is equal to the angle beta. So theta is equal to beta. That is according to theorem 5. That is from theorem 5. Theta is equal to beta from theorem 5. Now let's look at the theorem 6. AB is a chord. PQ is also a chord, and this is a circle with center O. The angle that the chord AB sustains at the center is beta, and the angle that the chord PQ sustains at the center is theta. Now if the length of chord AB is equal to the length of chord PQ, then it means that the angle that the chord AB and the chord PQ subtends at the center of the circle are the same, that means that beta is equal to theta, and so beta is equal to theta. That is theorem 6. Now let's look at the theorem 7. ABC is a triangle. Line PBS is a straight line. So line PBS is a tangent, and the tangent is a line that touches the circumference of the circle at a point. Now we can see that the tangent PBS touches the circle at the point B. AB is a chord. The chord AB subtends an angle of theta on the circumference of the circle, that is at the point C. The angle between the chord AB and the tangent, that is theta, is equal to the angle that the same chord AB subtends at the circumference of the circle, that is at the point C. Take note that AB is a chord. The chord AB subtends an angle of theta at the circumference of the circle, that is at the point C. PBS is a tangent, and the tangent is a line that touches the circumference of a circle at a point. So the tangent line PBS touches the circle at the point B. Now, the angle between the chord AB and the tangent at the point B is theta. Now, this angle theta here is equal to the angle that the chord AB subtends at the point C on the circumference. So the angle ABP equals angle ACB. That is theta equals theta. The angles are the same. Example. The diagram shows a circle PQRS with center O. So the center of the circle is O. The reflex angle at O is 204. Now at O, the reflex angle is 204, and this is the reflex angle, because you know that the reflex angle is an angle that is greater than 180 degrees but less than 360. So this is the reflex angle, 204 degrees. Angle ORS is 54 degrees. That is angle ORS. That's the angle at R is 54 degrees. And angle OPS equals X degrees. That is angle OPS equals X degrees. Now we have to find the value of X. We have to find the angle X. Now let's look at how best we can solve this problem. Now solution. PR is a chord. Take note that we have to find the value of X. We have to find the angle X. Now, the sum of all angles in a circular form is equal to 360. That is the circular angle form at the center equals 360. So if you want to know the angle POR, you have to subtract 204 degrees from 360, because the sum is equal to 360. I repeat, the sum of all angles in a circular form is equal to 360 degrees. And so now, angle POR, that is angle POR, plus 204 degrees is equal to 360. That is angle POR plus the reflex angle 204 degrees is equal to 360 degrees. Now if angle POR plus 204 degrees is equal to 360 degrees, if you want angle POR is equal to 360 degrees minus 204, that is plus 204 degrees on the left hand side becomes minus 204 degrees on the right hand side. And 360 degrees minus 204 degrees is equal to 156 degrees. That means that the angle at O, that is angle POR, is now 156 degrees. Now I repeat, the sum of all angles in circular form is equal to 360. So the sum of all the angles at the center of the circle equals 360. Now the reflex angle has been given to you 204. So if you want the angle POR, you have to subtract 204 from 360. Now angle POR plus 204 must be equal to 360. So plus 204 becomes minus 204 on the right hand side. So angle POR is equal to 360 degrees minus 204 degrees, and this is equal to 156 degrees. That means that the angle POR is equal to 156 degrees. Now, by the theorem 1, we know that the angle that the chord PR subtends at the center of the circle is equal to 2 times the angle that the chord PR subtends at the circumference. That means that the angle at S times 2 will give us the angle POR. I repeat, angle POR is equal to 2 times angle PSR. That is angle POR is equal to 2 times angle PSR. Why? Because PR is a chord, and the chord PR subtends an angle of 156 at the center. Now we know that the angle that the chord PR subtends at the center is equal to 2 times the angle that the same chord subtends at the circumference. That is at the point S. So it means that 156 degrees is equal to 2 times the angle at S. And so 156 degrees is equal to 2 times angle PSR. Now we are solving for the angle at S, that is angle PSR. So we divide both sides by 2. When we divide the right hand side by 2, we are left with angle PSR. When we divide 156 by 2, we have 78 degrees. That means that angle PSR equals 78 degrees. So angle PSR equals 78 degrees. That's the angle at S equals 78 degrees. Now let's proceed. PORS is a quadrilateral. That is PORS is a quadrilateral. It's a 4-sided figure. And we know that the sum of internal angles of a quadrilateral is 360 degrees. The internal angles of the quadrilateral PORS are X 204 degrees, 54 degrees, and 78 degrees. These are the internal angles of the quadrilateral. Now when we sum all these angles, we are supposed to equate it to 360 degrees, because the sum of all the internal angles of a quadrilateral is 360. So angle SPO, that is angle SPO, that's the angle X, plus angle POR, that is angle POR, that is 204 degrees, plus angle ORS, that is angle ORS, that's the angle at R, 54 degrees, plus angle RSP, that is angle RSP, that is the angle at S, 78 degrees. This is equal to 360. So X plus 204 degrees plus 54 degrees plus 78 degrees is equal to 360 degrees. Now 204 degrees plus 54 degrees plus 78 degrees is equal to 336 degrees. So on the left hand side we have X plus 336 degrees is equal to 360 degrees. because we are solving for x, we group the angles on the right hand side, and so plus 336 degrees on the left hand side becomes minus 336 on the right hand side. Therefore, x is equal to 360 degrees minus 336 degrees, and this is equal to 24 degrees. That means that the angle x equals 24 degrees. The angle x equals 24 degrees. Now we consider the example. We consider the example here. Now in the diagram, AB is a diameter. So we are told that AB is a diameter, and we know that a diameter is a line that divides a circle into two equal halves. So in the diagram, AB is a diameter of the circle ABCD. DC is parallel to AB. That is DC. The line DC is parallel to the line AB. If the line DC is parallel to the line AB, then it means that the angle at C is also equal to 25, because alternate angles are equal. Take note, it is from the question that DC is equal to AB. Now let's proceed. Angle BAC, that is angle BAC, is equal to 25. That is the angle 25 degrees. We have to calculate angle ABC. Angle ABC. So we have to draw a line from A to D. We also have to calculate angle CAD. That is angle CAD. Angle CAD. Now let's look at the solution. From the question, we were given this diagram. Now we draw a line from A to D, and that is the line as shown, A to D. We also draw a line from B to C, and that is the line as shown, from B to C. Now from the question, AB is the diameter of the circle, and you know that a diameter is a line that divides a circle into two equal halves. If AB is the diameter of the circle, then it means that the angle that the diameter sustains at the circumference is 90 degrees from the theorem. From one of the theorems. Now AB is the diameter of the circle. AB is the diameter of the circle. That means that the line AB divides the circle into two equal halves. We know that the angle that the diameter sustains at the circumference of a circle is 90 degrees. And so AB sustains an angle of 90 degrees at point C. Now from the question, we were given 25 degrees at point A. So we have 25 degrees at point A. Now we have 90 degrees at point C, and we have 65. Now we will look at how we arrive at the angle 65 degrees. Now we know alternate angles are equal, and because the line AB is parallel to the line DC from the question, it means that 25 is equal to 25 degrees here. Now let's proceed. Considering the diagram as shown, AB is a diameter. That is, AB is a diameter. Therefore, by theorem 2, angle ACB equals 90. That is angle ACB. The angle that the diameter AB sustains at the point C is 90, because C is on the circumference. The sum of the interior angle of the triangle ABC equals 180 degrees. And where do we have the triangle ABC? This is the triangle ABC. The sum of the interior angles is equal to 180 degrees. That means that angle ABC, that is angle ABC, plus angle ACB, that's angle ACB, which is 90 degrees, plus angle BAC, that is angle BAC, that is 25, as equal to 180. So angle ABC, that is the angle at B, plus 90 degrees plus 25 degrees is equal to 180 degrees. Now plus 90 becomes minus 90 on the right hand side. Plus 25 degrees also becomes minus 25 degrees on the right hand side. And so the angle ABC, that's the angle at B, will be equal to 180 degrees minus 25 degrees minus 90 degrees, and this is equal to 65 degrees. And that is how come we had the angle 65 degrees at B. That is how come we had the angle 65 degrees at B. Now, we are asked to calculate for the angle ADC. Now, after calculation ADC, the angle at D will give us 115. But let's see how we had the 115. We know that ABCD is a cyclic quadrilateral. That is ABCD is a cyclic quadrilateral. That is a quadrilateral within a circle. Now we know that the sum of the opposite angles is the same. So angle ABC, that is angle ABC, the angle at B, plus angle ADC, that is angle ADC, is equal to 180 degrees because they are opposite angles in the quadrilateral. Now angle ABC, that is ABC, the angle at B, has been calculated and we have 65. That means that 65 degrees plus angle ADC, that is the angle at D, is equal to 180. So making angle ADC the subject, it means that 65 degrees on the left hand side becomes minus 65 on the right hand side. And so angle ADC is equal to 180 degrees minus 65 degrees. And the answer is 115 degrees. And that is how come we have angle ADC, that is the angle at D, to be 115 degrees. Take note that we also asked to calculate the angle CAD, and from our calculation we had 40 degrees. Now let's see how we had the 40 degrees angle here. II. Since DC is parallel to AB, that is the line DC is parallel to AB, it follows that angle ACD, that is angle ACD, the angle at C, that is 25, is equal to angle BAC, that is angle BAC. That is alternate angles are equal. So since AB and DC are parallel lines, it means that the angle at A, that is BAC, is equal to the angle at C, that is ACD. So it's 25. Now the sum of interior angle of triangle ADC is 180. Where do we have the triangle ADC? We have triangle ADC. Now the angle at D is 115 degrees, that is 115 degrees. The angle at C is 25 degrees. Now let's see how best we can calculate for the angle at A, considering the triangle ADC. Now we know that the sum of the interior angle of triangle ADC equals 180 degrees. So when we sum all the three angles, we have to equate it to 180. So triangle CAD, that is CAD, that's what we are calculating for, plus angle CAD is what we are calculating for, plus angle ACD, that is 25 degrees, plus angle ADC, angle ADC, that is 115 degrees, is equal to 180 degrees. Now because we are solving for angle CAD, it means that plus 25 on the left hand side becomes minus 25 on the right hand side, and plus 115 on the left hand side becomes minus 150 on the right hand side. Therefore angle CAD, that is angle CAD, the angle at A, is equal to 180 degrees minus 115 degrees minus 25 degrees, and this is equal to 40 degrees. And that is how come we have the angle 40 degrees. Now let's look at this example. Considering the diagram, you can see that QXY is a triangle. PQR is a tangent at point Q. Now PQR is a tangent, that is PQR is a tangent to the circle at Q. So the line PQR is a tangent to the circle at Q. Angle YQR equals 54 degrees. Angle YQR is equal to 54 degrees. That's the angle at Q equals 54 degrees. And angle XYQ, angle XYQ is equal to 41 degrees. That's this angle. Now find the size of angle SQY. The size of angle XQY. So we have angle XQY. That we are supposed to find the angle at Q. Now let's see how we can solve this problem. Solution. From the question, angle YQR was given to be 54 degrees and angle SYQ was also given to be 41 degrees. Now PQR is a tangent to the circle at point Q, and you know that QY is a chord. The angle that the chord QY sustains at the point X on the circumference is 54, and so we know from Theorem 7 that the angle between the chord QY and the tangent line PQR are the same. I repeat, from the question we were given angle YQR to be 54 and angle XYQ to be 41 degrees. Now QY is a chord, and the angle that the chord QY sustains at the circumference, that's at point X, equals 54 degrees. Why is it 54 degrees? It is because the angle between the chord QR and the tangent line PQR, that is 54 degrees, is the same. And therefore, if the angle at Q, that is YQR, is 54, then it means that the angle that the same chord sustains at the circumference is also 54 degrees. Now, let's look at the solution itself. By Theorem 7, angle QSY, that is angle QXY, is equal to angle RQY, that is angle RQY. It means that the angle at Q, 54, is equal to the angle at X, that is 54. Now, how do we search for the angle at Q? That is XQY. Now, when we consider the triangle QXY, we have two interior angles, 54 degrees and 41 degrees. But you know that the sum of the interior angles of triangle QXY is equal to 180 degrees. And therefore, we have 54 degrees plus 41 degrees plus the angle at Q equals 180 degrees. So we have angle XQY, angle XQY, that's the angle at Q, plus angle XYQ, angle XYQ, that is 41 degrees, plus angle QXY, that's angle QXY, that's 54 degrees, is equal to 180 degrees. Now, angle SQY is what we are calculating for, plus 41 degrees plus 54 degrees is equal to 180 degrees. So plus 41 degrees becomes minus 41 degrees on the right hand side, and plus 54 degrees also becomes minus 54 degrees on the right hand side. And so angle XQY, that is angle XQY, the angle at Q, is equal to 180 degrees minus 41 degrees minus 54 degrees, and the answer is 85 degrees. 85 degrees. Now let's look at this example. Considering the diagram as shown, AB and CB are tangents. That is, AB and CB are tangents drawn from B to the circle of center O. So the center of the circle is O. The center of the circle is O. Find the values of X and Y. Find the values of X and Y. Now let's look at the solution to this problem. From the question, we are given this diagram. We are supposed to solve for the values of x and y. Now we are told from the question that AB is a tangent and BC is also a tangent drawn from B to the center of the circle O. Now the line OB, that is the line OB, bisects angle ABC. The line OB bisects the angle ABC, and therefore angle ABO, that is angle ABO, that is 31 degrees, equals angle CBO, that is angle CBO, that is x. That means that the value of x is also equal to 31 degrees. The line OB bisects angle ABC, and therefore angle x equals angle 31 degrees. So the value of x equals 31 degrees. Now if the value of x equals 31 degrees, then the total angle at B will be 31 plus 31, and that is 62. So angle ABC, that is angle ABC, the angle at B, the total angle is now 31 plus 31, because x is also equal to 31 degrees. So angle ABC equals 62 degrees. Now, a tangent at any point makes an angle of 90 to the radius drawn to the point of contact. So a tangent at any point makes an angle of 90 to the radius. So it means that the angle at A is 90 degrees and the angle at C is 90 degrees, because AB and BC are all straight lines. That is, they are all tangents. They are all tangent to the circle, and the angle between the tangent and the radius of the circle is 90, and therefore the angle at A is 90 and the angle at C is 90. So the angle OAB, that is OAB, that's the angle at A, is equal to the angle OCB, that is OCB, the angle at C, and this is equal to 90. Now ABCO is a quadrilateral, that is ABCO is a quadrilateral, and the sum of the interior angles is 360 degrees. So angle OAB, that is the 90 degrees angle, plus angle OCB, plus angle ABC, that is angle ABC, plus angle AOC, plus angle AOC, that's the angle at O, is equal to 360. The angle at A is 90, and the angle at C is 90, so we have 90 plus 90 plus the angle at B is 62, so we have plus 62 degrees, plus angle AOC, that is angle AOC, is equal to 360 degrees. Now 90 degrees plus 90 degrees plus 62 degrees is equal to 242 degrees. So we have 242 degrees plus angle AOC is equal to 360 degrees. Because we are solving for angle AOC, it means that 242 degrees on the left hand side becomes minus 242 degrees on the right hand side, and angle AOC is equal to 360 degrees minus 242 degrees, and the answer is 118 degrees. So angle AOC is 118 degrees. That is angle AOC. This angle is 118 degrees. This angle is 118 degrees. Now you know that the angle formed by a circle is 360 degrees. Now that you have gotten the angle at O, that is angle AOC, that is this angle. Now that you have gotten the angle to be equal to 118, it means that if you want to find the value of y, you can subtract 118 from 360, and that will give you the value of y. Now let's continue. The sum of all angles in the circular form is equal to 360. So because the sum of all angles in the circular form equals 360, it means that angle AOC plus y is equal to 360. So if angle AOC plus y equals 360, then In making y the subject, y will be equal to 360 degrees minus angle AOC. And angle AOC from our calculation here, we had 118 degrees. This implies that y is equal to 360 degrees minus 118 degrees, and the answer is 242 degrees. This is the end of our presentation on circular theorem.